Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to continue in the factoring chapter. We'll be in chapter 7, lesson number 8. Factoring by grouping. Well, what does that mean? Well, if you remember all the way back to lesson 1, I think it was, you remember that we talked about different properties of algebra. We talked about the distributive property and the identity property and the commutative property. The one that I want to focus on right here to help you understand this lesson is what's called the associative property. When we associate things together, what we're doing is we're grouping them into small groups. Okay, so let's take a look at this example I have written down here. This is on page number 256, page 256 in your book. And so what are we going to do here? Well, we're just going to group it together. We're going to associate things together. Notice that I can do it in different ways. I could associate these three together. Okay, that would be a trinomial and then a monomial. Another way that I could do that, and I'm not changing the value at all here, is to group it like this. I could have a monomial here and I could have a trinomial here. Well, another way that we could do it is we could group it in groups of two, okay? And I could group it like that. Well, what happens there? I have a binomial and a binomial. Well, for this example, this is the grouping that I'm going to choose, and I can choose different groupings based on the problem, okay? So different problems you can group it different ways, and you'll get different answers. You'll get the same answer, but you'll get to your answer different ways when you group them differently, but you always come out to the same answer, or you should, if you're doing it right. All right, so what do we have here? Notice what we have. I have an x cubed and an x squared. Well, I have something common. I can undistribute something right there. I can factor something out. It's a common factor. The x squared is common, so when I pull the x squared out of this, what am I left with? X plus, when I pull the x squared out of that, what am I left with? Just a 2. Now look over here. The 5 and the 10, what's common there? The 5 is our greatest common factor. The x isn't common. There's no x in the other one, so we just can pull out a 5, and then we get an x plus 2. Interesting. Okay? So here's what we want to do now. And that 5 is a positive 5 that I pulled out, right? So we could leave that positive 5 right there. In fact, it may be better, and the book does it like this, and that's fine. The book kind of leaves the plus kind of there outside, and so you undistribute and it goes with the sign, and that's probably the best way to do it. The way that I did it was fine too with the plus sign. It just gets a little weird with the negative sign, but with the plus sign, it's no big deal. All right, and so, well, that's kind of weird looking. So what's our answer, Mr. Steve? Well, let's take a look at it. Let's group those together now, because why? Because those are the common factors that came out. So we would have an x squared plus 5. That would be one factor. Now I want you to see what I have something that's common. X plus 2 and x plus 2, that's common. So when I take that out, I only take one of those. I don't need to take both. I take x plus 2. And you say, well, why do you only need to take one? Because we always only take one. Remember when we're common factoring something, let's say we're common factoring a 10 and an 8. I don't like that one. 12 and an 8. Okay. So 2, 6, 2, 3. 2, 4, 2, 2. Now remember, when I have a common, I only take one of those 2's, right? So it would be 2 times, and now I have another common 2, so I take another one. Well, the same thing is happening right here. I have a common x plus 2. So only one of those goes into my answer. When you have a common factor, you only pull out one of those for your answer. So this is going to be my answer. X squared plus 5 and x plus 2. X squared plus 5 and x plus 2. Done. Okay, so let's look at this example. What are we going to do here? Well, we're going to do the same thing that we did, but like I said, there's a little bit of a trick here with the negative signs, and it's not really too tricky. What we want to do, I, when there's negative signs, I'm going to want to put both of them inside of the parenthesis. Now, again, this is just a little bit tricky, but here's what we're doing. Okay. We are adding a negative 3x squared. You can always put an addition sign out in front of a negative sign, right? Because you're adding a negative. When do we use this? Well, when we're combining like terms. So let's say we're adding 3x plus a negative 4x. Well, we don't write the plus sign, do we? We just write 3x minus 4x. That's how we write it. But what is that really? Well, that's really 3x plus a minus 4x. You're adding a negative 4x to it. So here's what happens when we put this sign right here. When we put these in parentheses, we have to add a plus sign there, okay? And the reason we have to add a plus sign there is because of the whole undistributing thing that's going to happen, and you'll see what happens in just a second. But that plus sign is important there. We can't just leave it out, all right? So let's go ahead and just kind of work this problem now that we put that plus sign in there. Again, you can put plus signs wherever you want. They don't change anything. Now, we can't just add a negative sign. Negative signs change everything. So we can't just throw a negative sign wherever we want to. But we can throw a positive sign wherever we want to because nothing changes when we add a positive sign. Okay, so what do we do here? X squared, or x cubed and x squared. What comes out of that? Well, x squared comes out of there. What's left over? Well, we divide everything by x squared. X cubed divided by x squared is x. X squared divided by x squared is 1. Remember, anything divided by itself is always 1. Don't forget that plus sign right here. But you're going to see something here in just a second. It's going to be like, wait, what? Okay, so we'll put the plus sign there. And then what comes out of here? Well, the negative 3 is our GCF. So a negative 3 comes out of there, and we're left with, so divide everything by negative 3. And what happens? Well, that cancels, and we get x, and that cancels, and we get 1. Positive 1, right? Negative divided by negative gives you a positive 1. Interesting. Well, what's going on right here? Well, now that we brought that negative sign out, what does it mean when we have a positive negative right next to each other? All right, it means subtract. It means negative, so we can just kind of eliminate that plus sign. I told you it was important, and it is, but then it cancels, so it's kind of not important at the same time. But it is important that you understand that concept, that you're adding those two things together. Okay, we can't just leave the sign out. Why? What happens if we leave the sign out? Then it's multiplication, and we don't have multiplication going on right there. Okay, let me go back to that real quick. Sorry, I erased a bunch of stuff. We can't say that we have multiplication going on there because we don't. We have subtraction going on right there, or we have combining of like terms. We have addition. So put the sign. It's going to help you. All right, what are we left with? Well, we're left with that, so we put that together. Okay, so that's one factor. And then we have common factors right there, and so we have an x plus 1. That is our common factor. So there we go. There's your answer right there. Okay? And you say, Mr. Steve, can't we do anything else with that? No, that's called prime, because there's nothing that's not a difference of two squares. There's nothing else we can do with that. Even though it is a squared, we can't factor it because there's no factors of that. In the next one, we're going to see that we can sometimes do something with that one, but in that case, we can't because there's no perfect square number of 3. 3 is not a perfect square. So, all right, let's do this one. I've already got this one kind of divided up here. Now, this one's a little interesting because, look, we have a negative and a positive. Hmm. And that one's going to present just a little bit of a struggle there for us. So don't forget your sign goes in between those, okay? Because that has to show that there's an addition, not a multiplication. Kind of ran out of room there when I put the parentheses on it, but there we go. We'll put it up there. Not a problem. Now, what do we want to do? We want to factor out our common factor. What's common here? What's going to come out of there? Well, x squared is going to come out of there. What's left over? I don't know. Divide it by x squared, and let's find out. Well, we get an x minus, and that x squared cancels out to a 1. 3 times 1 is 3. So there we go. X minus 3. Don't forget that's a plus sign right there. Okay, that comes from right there between those parentheses. And now this is interesting right here. What we want to bring out here is what? Well, technically, what we want to bring out here is a negative 4, okay? And there's, well, let's just bring out the positive 4. All right, you'll see what I'm going to do here in just a second. Let's bring out the positive 4, because really the factor is a positive 4. It's not really a negative 4. So we're going to bring out a positive 4, okay? So what are we left with? We're left with a negative 1x plus 3. And we have a little bit of a problem, okay? We have a lot of bit of a problem right here. Our big problem is that this does not match this. So in other words, those are not like terms. However, they really are like terms, okay? Because what happens if we divide everything by a negative 1? If we divide this whole thing by a negative 1, what happens? Well, here's what happens. We get our like term. We change all of the signs of all of this stuff, all these associated things together. And we can do that. We're not breaking any rules of algebra right there. And so we get x squared times x minus 3. Now look what that becomes. Negative 4. And then this becomes our positive x. And this becomes our negative 3. Now look what happened. Negative x minus 3, x minus 3. So what happens is this ends up turning to a negative sign because we had to divide everything by a negative 1 to get the sign right. We needed to change these signs of this second one right here. This x, this negative x plus 3 needed to be x minus 3. And we can do that as long as we change all of the signs of these associated terms right here. Okay? And so what are we left with? X squared minus 4. So x squared minus 4. And then we have the common, which is x minus 3. Now, let's take a look at this. We're not done yet. You're like, oh my goodness, we're not done? That was really complicated. No, we're not done yet. Okay, we have one more thing that we need to do right here. Because look what I have here. I have x squared. I told you we were going to get one that we could keep factoring. We have x squared minus 4. Look, that's a perfect square, and that's a perfect square, and that's a difference. What we have there is the difference of two squares. So we're going to have an x plus 2, x minus 2. Remember, that factors out to a conjugate. So there's our conjugate because the middle number goes away. Middle number cancels when we FOIL. And then we have this as our other factor, x minus 3. So that would be our answer. X plus 2, x minus 2, x minus 3 would be the answer of that one. And that one's in your book too, so you can go through it. One thing that they do not show you in your book is they don't show you this step right here, where they take the negative sign out. In other words, they show you where they take out a negative 4, and I don't really love that because it's not really how you do it. You really have to do this divide by negative 1 thing to get all those signs to change. But they just kind of pull out a negative 4 randomly there. So don't get confused by that in your book. What's really happening is they're taking out the positive 4, and then they're dividing everything or multiplying everything by a negative 1 in order to change the signs. All right. Well, I think that's enough for today, right? That's enough for this lesson. You've had enough of that? All right, well, try some of those. Practice those, okay? They're not too bad once you get the hang of it. The big thing is pay attention to those signs. Make sure the signs are the same. You can't have a common factor if the signs are different. So we had to change those signs there at the end. All right, well, that's all I got for you today. Hope you learned something. If you didn't, go back and pull that back so you can figure out what's going on. We'll see you later. Bye-bye.